Hi everyone, this is Miss Peters. I hope you're all doing well and had a good weekend. I had a great weekend, well, as good as staying at home and doing nothing can be. This week is a busy week. I'm sorry, you have to have a test in or a major grade in all of your classes. I know this is a stressful week. I am here for you. Please message me with questions. I will do my very best to help you. So today we're going to review how to draw covalent Lewis structures and how to read that geometry chart. And so you probably want to have your notes packet open to an empty page. You might want to have the page where the instructions were open and then maybe a sheet of paper, whatever works best for you, and we'll get going. So first, I want to review the octet rule exceptions. Now, the octet rule, that is everything wants 8 valence electrons. They want to share 8 or have 8, but not everything does. So hydrogen only has 2 max. Beryllium, max of 4. Boron, 6. Now it's stable. That means it's happy. Once it gets 6, it's good. It doesn't need to have 8. And then if the central atom, the one in the center, is from periods, which is a row, 3 through 7, it can have more than 8. And that's called an expanded octet. So something like bromine can have more than 8 electrons. It can have 10, 12, while fluorine can only have 8. And so those are our exceptions. Okay, so we're going to draw the Lewis structure for CCl4. And step 1, I want you to count the total number of valence electrons in the compound and then divide that by 2. That tells us the number of pairs in your structure. Electrons stay in pairs, so a lot of times it's easier to just count the pairs. Looking at my periodic table, carbon is in group 4A or column 4A, so carbon has 4 valence electrons. Chlorine is in group 7A, so chlorine has 7, but there are 4 chlorine atoms in that formula, so I multiply that by 4, it's really 28. Total is 32 electrons or 16 pairs. 28 plus 4. Okay, so I'm just going to write up here, we've got 16 pairs we're dealing with. Step 2, the first atom in my formula will be the central atom unless it's hydrogen. So going to draw carbon in the center and then just draw the chlorines around it. Step 3, connect the remaining atoms to the center using a single bond. A single bond is 2 electrons or 1 line. So we connect everything to the center. Now, I have just used with those bonds 4 pairs. I have 16 pairs total, so we have 12 pairs left. And we're going to add those remaining 12 pairs to the outer atoms first to satisfy the octet rule. Leftover pairs go on the central atom. Every atom wants 8. I've used 4 pairs. I have 12 pairs left, and we're going to add them to the chlorines until all of my chlorines have 8. Now, with my stylus, drawing a little dot, it's kind of hard to see, so I'm going to use, instead of dots, I'm going to do a little line like that, but I still want you to draw them with dots, just so you can see easier. Okay, so we'll start here. We've used 4 pairs. There's my 5th pair, my 6th pair, my 7th pair, my 8th pair, my 9th pair, my 10th pair, 11, 12, 13, 14, 15, 16. So let's recount and make sure I've used all 16 pairs. 1, 2, 3, 4, 5, 6, 7, 8. I've used all of my 16 pairs, and then so we don't have any leftover atoms. Now let's count. Does every atom have 8 valence electrons? Well, this carbon has 2 here, oops, 2 here, 2 here, 2 here. Carbon has 8. Each of my chlorine has a single bond. That's 2. And then they've got 2, 2, 2 on the outside. So 6 plus 2 is 8. So everything has 8 valence electrons. This is the Lewis structure for CCl4. Now, it's not the case for this Lewis structure because my central atom was satisfied. My central atom had 8. But if my central atom did not have 8, then I would make a double or a triple bond. We're going to draw some more examples and we will practice when you use a double or a triple bond. Okay, so we're going to draw the Lewis structure for BeH2. So first, count our valence electrons. Beryllium has 2 plus hydrogen has 1, but there are 2 of them. So total that is 4 electrons or 2 pairs. The first atom in your formula is the central atom. Beryllium's in the center, hydrogen on both sides. And then we connect our outer atoms to the center with a single bond. So 1, 2. Now that's used both of my 2 pairs. That's a pair and that's a pair. Now, what was the deal with beryllium? Beryllium is an exception. Beryllium is happy with 4 valence electrons. Well, this bond is 2, this bond is 2, so beryllium is content. Hydrogen is also an exception. Hydrogen is content with, or it's happy, it has a max of 2 electrons. Each hydrogen has 2 from that single bond. So that's the Lewis structure for BeH2. Nothing else to do. Okay, next we're going to draw the Lewis structure for SF6. So sulfur is in group 6A, it has 6 valence electrons, plus fluorine has 7, and there are 6 of them. So really, that's 7 times 7. That is, no it's not, yeah it is. Math is hard. So 7 times 6 is 42, plus 6 is 48. That's not 7 times 7. Whatever, you get the drift. It's 8 times 6. Oh my god. So 48 electrons or 24 pairs. Don't try to multiply like I did just there. So sulfur goes in the center, and I'm just going to draw my 6 fluorines around it. And then we connect everything to the center with a single bond, and we have got 24 pairs. 1, 2, 3, 4, 5, 6. I've used 6 pairs. We now add electrons to the outer atoms to get all of my fluorines with 8. So I've used 6 pairs, 7th pair, 8th pair, 9th pair, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Now I've used all 24 pairs. Each fluorine atom has 8, and sulfur actually has 2, 4, 6, 8, 10, 12. But that's okay that sulfur has 12 because if you look at your periodic table, sulfur is in row 3 or period 3. So it can have more than 8. And there we go. That's the Lewis structure for SF6. Nothing complicated. Okay, next we're going to draw it for H2CO. Now, this is not a Lewis structure. I would expect you to be able to draw without me telling you how they're arranged. I wouldn't expect you to know when I draw this that it should look like that. Just FYI. Okay, so hydrogen. Hydrogen has 1, and there are 2 hydrogens, plus carbon has 4 valence electrons, And then oxygen has 6 valence electrons. And I don't know why I wrote an O and not a 6. Okay, so 6 plus 4 plus 2, that is 12 electrons or 6 pairs. So carbon's going to be in the center, oxygen's going to be connected to it, and then the hydrogens are connected to it. And again, I wouldn't expect you to know that shape or that it should be drawn like that. So I've just used 3 pairs. Now, what was the deal with hydrogen? Hydrogen's an exception. Hydrogen can only have a max of 2 valence electrons. So each of my hydrogens is done. We're not going to add dots to it because they already have 2 from the single bond. I have 6 pairs. I've used 3. Where do we add pairs to? Add them to the outer. Well, we can't add them to hydrogen, so we're just going to add them to oxygen. So that's 3, 4, 5, 6. Done. I don't have any more pairs. Now let's double check. Are all of my atoms happy? Hydrogen's happy. It has 2. That hydrogen has 2. Carbon has 2 here, 2 here, 2 here. So carbon only has 6. Carbon is not content because carbon's not an exception. Carbon needs 8. And then oxygen over here has 8. This is where we're going to erase a pair and make a double bond. Because when I erase that pair and I make a double bond right here, now carbon and oxygen are sharing 4 valence electrons. Carbon has 2 over here, 2 over here. Now carbon has 8. Oxygen still has 8 because making a double bond did not take them from oxygen. Oxygen is just sharing it with carbon right now. But I think the key thing is to remember we only made a double bond because we had put down all of our pairs and the center atom still did not have 8. A lot of people will start just making double bonds. Once your center atom has 8, you don't make a double bond, ever. Okay, and we're going to do another example. NH4, 1 positive. So N, nitrogen, 5 valence electrons, plus hydrogen has 1. There are 4 of them, and then that 1 positive. That means that it's a cation, and it has lost an electron. And so right now, 5 plus 4, that's 9 electrons. Well, it lost one, so 9 minus 1, this is 8 electrons we're dealing with, or 4 pairs. Now, you might be wondering, this is a cation. Why are we going to draw the Lewis structure like a covalent compound? NH4, the nitrogen and the hydrogens have covalent bonds to each other, but this whole thing will form an ionic bond with something negative like fluorine. That will be an ionic bond. But we're drawing the Lewis structure for NH4. That is a covalent bond. Don't let the charge thing freak you out is what I'm saying. And if you're like, I don't get what you're talking about, don't worry about it. Okay, for the sake of space, I'm going to erase that. All right, so NH4, we've got 4 pairs. Nitrogen is in the center, hydrogen around it, and we connect everything to the center with a single bond. 1, 2, 3, 4. I've used my 4 pairs. Hydrogen is an exception, can only have 2, so all of my hydrogens have a single bond. They have 2, and then my nitrogen has 2, 2, 2, 2. Nitrogen has 8. It is happy. And the only thing we add different is because it's got a charge, we're going to put it in brackets, which I drew mine kind of funny, and write the charge outside of it, 1 positive. That would be the correct way to draw the Lewis structure for ammonium. Okay, we are going to move on. If you could go to your notes packet, the big table titled, it's the whole page, VSEPR Theory. Go there, and I'll give you a minute. So, VSEPR theory stands for valence shell electron pair repulsion. This theory is just the theory of what shapes molecules will have, and it is based on the premise or the fact that there's repulsion between pairs of valence electrons. Now, do you remember earlier this year we talked about charges? If you've got something positive and something negative, they attract each other. Opposites attract in chemistry and in life. Maybe not people, but charges do. And then if you had a positive and a positive, that would repel. They would want to go away from each other. And then if you have a negative and a negative, that would also repel. Opposite charges attract. And so electrons, they're in pairs, but they're all negative. So one pair of electrons repels another pair of electrons. And this theory is just the electron pairs repel each other. And so atoms arrange themselves to where the electron repulsion is minimized, or pairs of electrons are as far apart from each other as possible. And I'm going to erase this right here. Looking down here, we have the Lewis structure for BeH2. It has two single bonds. We drew it earlier, and they are actually, this is a linear structure. They're 180 degrees apart. This gets those bonds as far apart as possible. They don't want to be close to each other, and that's why it has a linear structure. This is why when something like water looks, not hydrogen in the center, oxygen, hydrogen, hydrogen, it bends down because there are pairs of electrons, and these pairs push those pairs away. Really, you don't need to understand this. I just wanted you to know a little bit about this theory and why it occurs. So looking at our table, how we read this, these two columns, boom and boom, determine what shape something has. And the way we read it, atoms bonded to the central atom, that's how many letters are bonded to the central atom, not how many lines. And then lone pairs of electrons. A lone pair is a set of dots. So how many sets of dots are on the central atom? And that will tell you what shape it has. So if something has two atoms or two letters bonded to the center and one lone pair, it's bent or angular. And you just call it bent or you call it angular. You don't have to say bent or angular. And when you draw its Lewis structure, you're going to draw it like that shape because it bends down. It's not linear because that pair up top pushes the single bonds away. So this chart, extremely important. Okay, so BeH2, we've already talked about it. It has two atoms attached to the center and 0 lone pairs. Oops. So it is a 2-0. This Lewis structure is linear, and they're 180 degrees apart. The little GIF right there shows it moving, but they are as far apart as they could possibly be. Next one, we drew this earlier. What shape would this have? So my carbon has 3 letters attached to the center, so it could be that one or it could be that one. But how many lone pairs or how many dots are on the center atom? None. So it's a 3-0. It is a trigonal planar. And the little GIF shows what it looks like. And they're not 180 degrees apart. I don't know the angle. Guess what? You don't have to know the angle, but they're spread as far apart as possible. Next one, OCl2. And just FYI, this Lewis structure is missing some dots. Boom, boom. Okay. For this one, the oxygen has 2 atoms attached to the center, so it could be linear, or it could be bent, or it could be the other bent. And then it's got 2 sets of dots on the center atom, one here, one here. So it is bent or angular. Now, there's not really a difference between this bent and that bent. They are both bent. And you draw them both like this. Next one, CCl4. So carbon has 4 atoms attached to the center and no dots on the center. It is a tetrahedral. Now, these shapes are not the only shapes that exist. These are just the most common ones and the only ones you need to know. There are other shapes that things take. You just don't need to worry about them. And that's a tetrahedral. And then a few more. NF3, nitrogen has 3 atoms attached to the center, 3 letters, and then that one pair on it. So that one is a 3-1 trigonal pyramidal. And if I were to redraw that, which being a good chemist I would have my N, my F's going down, and the lone pair up top. And that right here is what it looks like. Next, PF5. So my phosphorus has 5 atoms attached to the center, no lone pairs on the center. It is a trigonal bipyramidal. And then last but not least, it's the example in there, SF6. Sulfur has 6 atoms attached and no dots on the center. It is an octahedral. And it would be drawn like it is there. And then again, we got the little 3D GIF of it. So today we reviewed how to draw covalent Lewis structures and the shape they will have. You should go to Canvas now and take the little practice quiz. It is just for attendance and to see how you did. You do have multiple options or multiple attempts on it in case you mess up, and it'll help get you ready for the test on Thursday. Hope you have a wonderful rest of your day.